And this is the review for the parallel lines and perpendicular lines test with the proofs. So the first two we did in class together with the transitive property. So these are just fill in the blank ones. So we have our given n is parallel to m. Just run highlighter. So n is parallel to m. Right, so here's this one. So we know these two lines are parallel. So since those lines are parallel, we know our alternate interior angles are going to be congruent. So this is going to be angle 1 is congruent to angle 3. Okay. You can't say angle 3 is congruent to angle 2 because we don't have P and R as parallel. What we have here is n and m. So since n and m are parallel, the only pair of alternate interior angles we can put there are going to be 1 and 3. Okay. And then since angle 1 is congruent to angle 3, and angle 1 is congruent to angle 2, we can use the transitive property. Transitive property. Okay, which says that if A is equal to B and B is equal to C, then A is equal to C. So here we have angle 3 is congruent to 1 and angle 2 is congruent to 1. So they're both congruent to angle 1, therefore they're congruent to each other. Angle 3 and angle 2 are both congruent to angle 1, therefore they're congruent to each other. 3 and 2 are both congruent to angle 1, so they're congruent to each other by the transitive property. Now that we know 2 and 3 are congruent, we have alternate interior angles that are congruent, so we can use our converse to the alternate interior angle theorem. Right? Our converse theorems are the ones that get us parallel lines. So converse to alternate interior angle theorem, converse to alternate exterior angle theorem, converse to corresponding angle theorem, and converse to same side interior angle theorem. Okay, we need these kind of angle pairs to be congruent. If they're congruent, we can say the lines are parallel. In this one, if same side interior angles are supplementary, we can say the lines are parallel. So here we have alternate interior angles that are congruent. Therefore, the lines P and R are parallel by the converse to the alternate interior angle theorem. So let's look at 2. Okay, and let's fill in the blank. So here we have G and H are parallel. So here's G and H are parallel. And it says angle 1 is congruent to angle 3. Well, since G and H are parallel, we know by the corresponding angle theorem, corresponding, okay, or we put CAT, corresponding angle theorem, that if the lines are parallel, corresponding angles are congruent. Okay, the temptation here is to say that angle 3 is congruent to angle 2 by the same thing, the corresponding angle theorem, but we can't do that. The reason we can't do that is because these lines are not parallel. We don't have it written anywhere here that P and R are parallel, so we can't use the corresponding angle theorem. What we can do is use the transitive property. The transitive property tells us since angle 3 is congruent to angle 1 and angle 2 is congruent to angle 1, that they're going to be congruent to each other. Since both angle 3 and 2 are both congruent to angle 1, they're congruent to each other. So that's going to be angle 2 is congruent to angle 3. And since angle 2 and angle 3 are corresponding angles that are congruent, we can use the converse of the corresponding angle theorem to say that lines P and R are parallel. Since our corresponding angles are congruent, the lines are going to be parallel. P and R are going to be parallel. Number 3. Do another fill in the blank here with transitive. So they're giving us that P and T are parallel. Okay. That means we can have alternate exterior angles here. So it's going to say angle 1 is congruent to angle 2. That's the alternate exterior angle theorem. And then they're giving us that Q and R are parallel. So since Q and R are parallel, we know our corresponding angles are congruent. So we can use the corresponding angle theorem. CAT, corresponding angle theorem, which says that if the lines are parallel, corresponding angles are congruent. So we'll say angle 2 is congruent to angle 3. And since both angle 1 and angle 3 are both congruent to angle 2, they're congruent to each other, and we call that the transitive property. The transitive property. The transitive property. Okay, number 4. So as much room as possible. So we start with our given. Okay, and we're going to be given that A is parallel to B and C is parallel to D. So they're telling us A and B are parallel. Since A and B are parallel, we know that 3 and 4 are alternate interior angles. So those alternate interior angles are going to be congruent. So we're going to say angle 3 is congruent to angle 4. That's our alternate interior angle theorem. Alternate interior angles are congruent. Okay, and again, our steps here are in theorem, definition, and then substitution if we need to. So since they're congruent, we know the measure of angle 3 equals the measure of angle 4. That is definition of congruent. We also know that C is parallel to D, so we know our same side interior angles are supplementary. So step 4 here, right, there's nothing to substitute in yet. So step 4 here is going to say angle 3 and angle 2 are supplementary, okay, because they're same side interior angle, so that's the same side interior angle theorem. We then use our definition of supplementary. Okay, which says the measure of angle 3 plus the measure of angle 2 equals 180. We know that the measure of angle 3 equals 4, though, so we can do substitution. And I know this is a little bit more tricky because it doesn't have the numbers. The one on the quiz had numbers, but it's the same idea. Instead of 3, we're going to replace that with the 4. So we're going to substitute in the 4 for 3. So substitution gives us the measure of angle 4 plus the measure of angle 2 equals 180. Okay. And then we have 2 and 1 are vertical. So by the vertical angle theorem, okay, we know that angle 1 is congruent to angle 2. So by the definition of congruent, we know the measure of angle 1 equals the measure of angle 2. Congruent. And then we can substitute in. So we are trying to get 1 and 4 as supplementary. So we need to say that the measure of angle 1 plus the measure of angle 4 is 180. So we can substitute into this equation right here. Okay, right here. We can substitute this in for the 2. So now we have the measure of angle 4 plus the measure of angle 1 equals 180. Right, so we're replacing in this equation right here. Right, we're replacing the 2 with the 1. Now we have measure 4 plus. Okay, and that was substitution. Right, and now that we have 2 angles that add to 180, we know those are supplementary. So we can say angle 4 and angle 1 are supplementary. And that's our definition of supplementary. Okay. So we started with what we had. So we start at I'm not sure. I went backwards. I'm not really sure why I went backwards. Again, either way is fine. We should have probably started at 1, done vertical, same side interior, and then alternate interior. I started at 4. Maybe that was a mistake. But it's the same process, right? So 4 and 3 are alternate interior. Definition of congruent tells us their measures are equal. 1 from 3 to 2 is same side interior. So they're supplementary. Supplementary means their measures add up to 180. We can substitute in 4 for the 3. Okay, then we have vertical angles are congruent. So the measure of angle 1 equals the measure of angle 2. We can substitute that in for the 1, for the 1 in for the 2, because the 1 and 2 are equal. So we substitute in for the 2, so we get the measure of angle 4 plus the measure of angle 1 equals 180. And since 4 and 1, the measure of 4 and 1 both add up, or since the measure of angle 4 plus the measure of angle 1 is 180, we know they're supplementary by the definition of supplementary. Okay, there's another one like that. So we'll get to it. Okay, 5 here is a fill in the blank. Doesn't look like it's going to fit. I'll have to zoom out. I don't know if we can see, but you should have it on yours. So first step's given. So L1 and L2 are parallel. That's given to us. So it's telling us linear pair postulate. So we're trying to get from A to G. So it wants to do a linear pair. Okay, so then they went C to G. So we need to do A to C, right? So they're going from C to G, which means we need here to go from A to C. So linear pair postulate is going to tell us that angle A and angle C are supplementary. Okay, you can't see it. I'm sorry. It doesn't really fit in here very well. Angle A and angle C are supplementary. Since angle A and angle C are supplementary, we know the measure of angle A plus the measure of angle C equals 180. That's what supplementary means. It means their angle measures add up to 180. Since the lines are parallel, we know C and G are congruent by the corresponding angle theorem. And the definition of congruent tells us the measure of angle C equals the measure of angle G. So we have 2 equations here. Now we can just do substitution. Right, we're replacing here C with G. So we're going to plug the G in for the C. So we get the measure of angle A plus the measure of angle G equals 180. That's substitution. Six. We can zoom back in probably. So we have angle 1 and angle 2 are congruent. That's given. Okay, and then we say L is parallel to M. So if L is parallel to M, that means we have to use one of our converse theorems. Okay, which converse theorem though? Well, let's look at 1 and 2. Those are congruent corresponding angles. So since the corresponding angles are congruent, we know by the converse to the corresponding angle theorem, that L and M are parallel. Once we know L and M are parallel, we know that alternate interior angle, so these lines are now parallel. So we know our alternate interior angles are going to be congruent. So angle 4 and angle 5 are congruent by the alternate interior angle theorem. If the lines are parallel, alternate interior angles are congruent. We're also given that angle 3 is congruent to angle 4. So again, they could have done this, right? And that would have been fine. That's what we've been doing. But if they want to write it as two separate steps, that's fine. It's no big deal. They're just rewriting it down there instead of up here for their second given, because we were given two things. Since angle 3 is congruent to angle 4 that was given, we know angle 3 is congruent to angle 5. So since 3 and 5 are both congruent to angle 4, they're going to be congruent to each other by the transitive property. Transitive property. Okay. And once we know 3 and 5 are congruent, we have corresponding angles that are congruent. So what can we conclude about the lines if our corresponding angles are congruent? We can conclude that they're parallel by the converse to the corresponding angle theorem. Converse to the corresponding angle theorem. Okay, 7. Given that A is parallel to B and X is parallel to Y, so as an added bonus, if you guys take the time to actually watch the videos, the two level 4 proofs, one will look like this, except instead of just in general, it'll have an angle measure like it did on the quiz. And then one will be a proof of perpendicular lines like number 8. So if you want to get level 4, you should be able to do 7 and 8 here. But again, 7 will be a little easier because you actually have numbers to work with. You'll be proving that the measure of angle 15 is, 110 or something like that. For whatever reason, you guys find it harder when you're not dealing with numbers, when you're just simply dealing with expressions and stuff like that. Well, let's do our statements given. And this is very similar to number 4, so same idea. Statements, reasons. Okay, so this is our given. Not that I want you memorizing the process, it's just, I don't know, I get that these are difficult. So we're given that A is parallel to B, and we're given that X is parallel to Y. So A and B are parallel, X and Y are parallel. So we want to get from 4 to 15, so let's start at 4. Many different ways to do it. I want to get there in as few steps as possible. So how about, well, they're going to be supplementary. We're going to have to do 3 steps. 4 to 10. Yeah, I don't think we can get there. So I'm going to do 4 to 10, 10 to 14, and then 14 to 15. I'll make sure you guys can get there in 2 steps. I don't think we can get there in 2 steps here. 4 to 6, and then 6 to 16, and 16 to 15. Go 4 to 8. All right, let's do that. Let's do 4 to 10, 10 to 16, 16 to 15. All right, so we want to go from 4 to 10. So we know A and B are parallel. So alternate interior angle theorem tells us that angle 4 is congruent to angle 10. We know by the definition of congruent that the measure of angle 4 equals the measure of angle 10. That's definition of congruent. Okay, let's go to our next one. 10 to 16 are all, I'm sorry, 4 and 10 are alternate interior. Let's do 10 to 14. So just so we don't do the same one. So I'm going to do 10 to 14. Those are corresponding angles. We know X and Y are parallel. So we're going to use the corresponding angle theorem to tell us angle 10 is congruent to angle 14. Okay, so we know the measure of angle 10 equals the measure of angle 14 by the definition of congruent. We can then substitute in, again, we want 4 and 15, so we're going to have to bring 4 along with us. So we're going to substitute in 4 for the 10, because we know the measure of angle 4 equals the measure of angle 10. So substitution is going to give us the measure of angle 4 equals the measure of angle 14. Now we're at 14. The 15, that's linear pair, so we're going to use the linear pair theorem. Linear pair theorem, which tells us linear pairs are supplementary. So we know that angle 14 and angle 15 are supplementary. Then we can use the definition of supplementary. The definition of supplementary is going to tell us that the measure of angle 14 plus the measure of angle 15 equals 180. Okay, luckily we know that the measure of angle 14 equals the measure of angle 4, so we can substitute that in. So the measure of angle 14 equals 4, so we can do measure of angle 4 plus the measure of angle 15 equals 180. Okay, that's substitution. Okay, and if the angle measures add up to 180, what do we know about the angles? We know they're supplementary. So angle 4 and angle 15 are supplementary. That's the definition of what supplementary angles are. Definition of supplementary. The internet's still out. Been out for like 3 hours. So we're good on that one. The last one here, again, this one you want to be able to do for the test as well as a level 4 question. So we have statements, reasons. So this is given. What are we given? We're given 3 things here. We're given that TS is perpendicular to TR. Okay, but we're also given that the measure of angle STA equals 5x plus 12, and the measure of angle ATR equals x plus 30. So we're also given this. So let's use the fact that we have perpendicular lines. Perpendicular lines mean that we have right angles. So we know angle STR is a right angle. Okay, that is definition of perpendicular. Perpendicular lines form right angles. Okay, and then by the definition of a right angle, we know the measure of a right angle equals 90. So we're going to say the measure of angle STR equals 90. Okay, we're trying to solve for x. So we need an equation. To get an equation with angles, we need to use the angle addition postulate. Okay, the angle addition postulate is going to tell us the measure of angle STA plus the measure of angle ATR equals the measure of angle STR. The 2 small angles add together to form the big angle. We know the measure of the small angles are 5x plus 12 and x plus 30, and we know the measure of the big angle is 90. So we can substitute all those in. And then we can solve. So we can combine like terms or add right? So 6x 42 equals 90. So that's going to be addition. Okay, we can subtract 42 from both sides. That's going to give us 6x equals 48. So that's subtraction. Then we're going to divide 6 on both sides. That's the division. This is the property of equality. We're going to do the division property of equality because we're dividing from both sides, and we're going to get x equals 8, right? Because we're dividing by 6. So we end up with x equals. Okay. So because you have perpendicular lines, you have a right angle. We know the measure of right angles are 90 by the definition of a right angle. We can use the angle addition postulate because we have angles, and the two small ones are going to add up to the big one. Substitute in all the stuff we know, 5x plus 12, x plus 30, and then the measure of angle, STR, is 90. And then addition, add them together, combine like terms basically. Subtraction of property of equality because we're subtracting from both sides, and then division property of equality because we're dividing from both sides. Okay, and that's the proofs practice review for the final. Again, you want to be able to do 7 and 8 for level 4s.